Hello and welcome to today's lesson of 3D drawing for your model railway. Today what we're going to be looking at is drawing the W-irons and axle boxes in this sort of area around the wagon that we've continued from drawing the other day with the Lowmac. To be able to assist with this, I've actually spoke to a friend called Paul Wade who's given me permission to show a couple of the photos that he's supplied me of this wagon to give you a good idea of what we're actually looking at. Okay, so looking at the wagon itself, what we've got here is the W-iron in this area here, axle box sitting in front of it, and then you've got your spring above, which the ends are attached to these hangers which are on the wagon, which is going to be the biggest problem really for this wagon, because normally you could do axle boxes and W-irons in two ways. You could either print them as a separate part and then glue them on as like a kit built type thing as you go along, or you could do them as part of the model. Now these bits here are going to make it really difficult to have them as a separate part, because obviously you can't then attach these bits here to the front here. So realistically in Engage what I'm going to be looking at is having this as part of the body itself. If I was to do it for some of the WO boys, I'd probably just leave these bits off and then they'd have to do those using some plastic art or something like that. Or they could have it as part of the body as it is, and then just try and make their wheels fit around on the inside, because I know that sometimes they use a brass etch W-iron or axle holder on the inside. So yeah, thanks to Paul for allowing me to use this photo to show you what we're going to be doing today. So it's in this area here. So let's jump across back to Fusion. Okay, so now we're back in Fusion. Next thing we've got to look and think about is how much room we're going to have on the inside here. So what we can do is we can zoom in on the bottom edge here. This is going to give us the length from that point to that point. If I just click on this edge, you can see down the bottom corner we've got a length of 17.4 millimeters. Now measuring Engage axles, the pin points are 15.1 millimeters. So realistically we've only got 2 millimeters of play here, and the axle boxes, looking at the pictures, are pretty much in line with the edge of the sole bar here. So we're not going to have a lot of room there. Now the preferred option when you're modelling, obviously with axles, is to have a brass pinpoint axle cup in there. But I've found that if you're modelling to scale and you want it to actually look as it should do without taking any compromises, you realistically aren't going to be able to fit those in. Now obviously with the danger then is not having a brass axle cup is you're then potentially then wear away your resin. Now what I've sort of done to overcome this is I've just taken a file to the end of the pinpoint and just taken off just a small amount of the end of the pinpoint, so it's not quite so sharp, and it also gives you that little bit more room on the inside. So I'm probably taking it down to 15, maybe slightly below 15 millimeters, but it just takes away that sharp pinpoint. I haven't had any issues from doing that with running some of my stock on the layout, but obviously the preferred method is to use one of the brass pinpoint cups. Right, so the first thing I'm going to do in the software is to make our life easier. We're not going to draw it 4 times, only do it once. We're going to use our sketch history to just roll back the sketch history past the mirrors, so we're only going to be having one part that we're working from. Okay, so next thing I'm going to do is I'm going to create an offset plane that we're going to use to draw the W-iron. So we're going to construct an offset plane, and we're going to do it from this back face here, and we're going to drag that across to about there in position. Okay, so now we've got that offset plane. If we spin this round so we're looking face on, and we're going to turn on the canvas that we were using with a picture of the wagon on it. We're going to use this to actually be able to draw the W-iron. So as you can see, it's in there drawn on, so we're going to just create a sketch on that offset plane that we've just had. Okay, and we're going to copy around this W-iron. So we'll come down 2 millimeters and we'll angle across. Okay, and then it comes to the midpoint of the axle. And then we'll draw a line upwards and click on OK. And we're going to use that line there as a construction line. Okay, so the next thing we're going to do is select those and we're going to mirror those using that construction line there. So that we now know that both sides of our axle is going to be the same size and shape. Okay, obviously that's coming up behind into the body here. And to be able to extrude that, because as you can see it's not changing colour like the rest of it, I need to draw a line across here to join those up, so that's now a closed face. Okay, I can now come in and extrude on that surface. So if we extrude that, we'll turn that around so we can see what we're looking at, and we're going to extrude inwards by 1 millimeter, and we're going to tell it to join. Okay, so what we've got here now is the distance from this position to this position. Okay, we can inspect that at the top here with a measure tool. This should be about 6 millimeters. So from that corner to that edge, 6 millimeters. And if I measured my wheel, and the outside faces of the wheels across the axle is just slightly over 11 millimeters. So obviously that's going to give me about 0.5 millimeter gap each side. Now I can change this, and I probably will change this a little bit. I'll probably just extrude out on this side slightly and dig this back in slightly. But the best way I can do that is if we go back to the sketch history, edit the offset plane, and we're going to change that offset plane to 7.3 millimeters. What that will do is that will move this extrusion across with it. So if we now inspect this, we can measure from that corner to that face, and we've now, as you can see, got 6.3 millimeters, which gives us 12.6 millimeters in total, which is going to give us about 1.6 millimeters clearance across the axle between the wheel faces and the back of what we're printing. So that I'm going to be quite happy with there. Okay, so the next thing we're going to do is we're going to try and draw this backing plate off the axle box here. I'm not going to try initially with this strap here. I'm just going to do this square rectangular backing plate before the axle box. So come back into Fusion. We'll create a sketch on the front surface of the W iron. I'm going to use the center point rectangle, and we're going to define that point on that pinpoint where the axle's marked. I'm just going to drag that out slightly. Okay, I'm going to go there. Okay, and what I need to do now is make sure this is centered across our drawing. And you can see that it's not, it's offset slightly. But that's because I don't think the drawing is 100% accurate. So we're just going to make the best of it. We're going to define the distance from that face to that face. I'm going to go with 1.3 millimeters, and then we'll do the same on this side, that face to that face, 1.3 millimeters. Okay, now we know that that's going to be centered across that position there. We can then define the height. We can go 2.5 millimeters, and we'll define the height from there to there. It looks a bit low to me. Yeah, it is. So I'm going to bring that up a little bit. So let's go for 1 millimeter. See where that moves it to. That's way too high. So go 0.5, and then we'll probably just bring this down slightly to 2.3. Okay, so now we've got this in the position where we want it. We're then going to extrude this forward. And looking at the diagram or the picture that we're looking at, it's not a particularly fat plate, so we're going to come 0.3 millimeters. Okay, so we don't need this canvas anymore, we can turn that off. So we've got this back plate, which as we can see, that's what we're working on here. Next we're going to do is the axle box. Okay, now if you look at that, it looks like it's not square, it looks like it's got an offset lump coming outside here. So it could be two rectangles with another rectangle coming across the middle here. So that's basically what I'm going to draw now. In the double O, if you've got better pictures, you can maybe, I don't know, maybe that's diagonal there, I'm not quite sure. But we'll go for 2 rectangles. With Engage, you're not going to notice it, to be fair. So let's jump into Fusion again. We'll create a sketch on this front plane. Okay, and then we'll go back to the center point rectangle. We'll find the center point for this face, and it was full height to the body, so we know that's going to be 2.3, and we're going to go for 1.8 wide by 2.3. Okay, so happy with that. So you can fix that in position. And the next thing we're going to have is a rectangle that goes the other way. So again, we'll go for our center point rectangle. Yeah, we'll go 1.1 millimeters tall and 2.4 millimeters long. Okay. So then if we select all of these features, we can then extrude it. Okay, so that's ready for the extrude. Let's have a quick look at the picture. Okay, and we're going to drag that about 1 millimeter. Okay, how's that look? Yeah, looking good. Happy with that. Okay. Next, we're going to draw this strap coming up the back here. Actually, no, we won't. What we'll do is we'll draw the spring on the top here. Now, springs can be a bit of a pain to draw, and I just go generally to draw it so it looks like a spring. It's never going to be perfect. You're never going to get it looking exactly the same, and you're definitely in Engage not going to be able to define the gap between each of the leaves on there. So I just sort of go for a shape that looks reasonable, and then work from there. Okay, so I'm going to start this leaf by drawing on that back plate there. Initially, I'm just going to draw a center line coming up here, and I'm going to change that line by selecting it into a construction line so I can then work from my midpoint here. Okay, so the next thing I'm going to select is a line and make sure that it's not on construction line. Actually, I don't want a line, I want a... I'm going to go for a line. I'm going to start it about halfway up, and I'm going to bring the leaf across 2.5 millimeters. Okay, and I'm going to draw a line down. Because the leaves are slightly curved, I'm going to use a bit of an arc here. I'm going to go 0.15 millimeters. Okay, the next thing I'm going to do is come into arc here, and I'm going to create a 2-point arc, use the 2 end plates, and I'm just going to move this around so that I've got that curved and it's on the straight line here. I'm going to go back there. Okay, and then I'm going to fix that into position. Okay, next I'm going to bring a line down here, 0.2 millimeters, and what I'm then going to do is I'm going to use an offset tool. I don't want the tangent, I don't want change selection. Turn that off. Actually, come back to offset, turn change selection off. I want that line, and I only want it 0.2 millimeters. And then I do again, offset line, 0.4 millimeters. And again, I keep working my way down until I get down to this top of the axle box here. So offset line, 0.6 millimeters. Okay, so I'm going to go back in and delete that line out because I don't want that there now. Okay, so what I've now got is the leaf springs, each one coming down here. Now there's not going to be as many here as there is on the actual model, on the actual wagon itself, because you just can't define it at this sort of scale and size. So I'm just going to draw a line down there that connects, and then I'm going to work my way down the leaves here so I get what looks like the same stepping design. Start there, come down, there and down. Okay, and then what we can do is define that point to that point. It's 0.5 millimeters, and then do the same here. 0.5. Okay, and now we've got these here. What I'll do is draw a line that comes down this center line there, connects. That then will now enable me to select all of these like that, and then I can extrude that 0.4 millimeters, and then I can mirror this object across. So if we go to create, mirror, select those features, and the mirror plane will be that base there. Okay, just check how it's all the same in one body. Okay, so you can see I've now got the shape of my leaf spring. I'm not going to waste my time drawing all these lines up and putting a tiny little sliver in there, because in Engage you just won't see it, and in Double O you're probably not going to see it even if you look at them. They're the smallest of gaps between each leaf, so realistically it's just not really worth it. Okay, so the next thing we're going to do is there's a cube or a box that goes over the top of the springs here, so we're going to draw that same thing on there. So we'll create a sketch on that face, 2-point rectangle, and we're going to draw that here, define the distance from there to that point, 0.3 millimeters, and the same, there's 0.3 millimeters. Height wise, it goes, if we look at the picture, it goes up above the leaf springs here, so we'll go up above as well and define that length, 1.3 millimeters, and then what we can do is extrude those back into the face, making sure that it joins and not cuts. And what we'll do back is also go back into that sketch, and we'll extrude it forwards as well. Sorry, don't do that way. I want to go back into edit feature and do two-sided extrusion, and we'll come forwards slightly. Okay, so the next thing we'll do is this strap here with these 4 rivets on here. Let's see if there's a clearer picture on the other side. No. So we'll go with 4 rivets for the time being. So if we jump back into Fusion, create a sketch on that plane and a rectangle coming up, and we'll come just below the spring there, and we'll define it as 0.4 millimeters in width and 2.6 millimeters in height. Okay, and we want a construction line here. Turn that into construction, and the reason for that is I'm going to mirror this across. Actually, ignore that, because I'm going to draw the extrude and draw the rivets on first, then I'll mirror it across. So if we extrude this forward slightly, we can't come as far forwards. Can't come as far forward as this plate here. So if we just extrude it 0.2 millimeters. That looks okay. And then we'll draw the rivets on the front here. Now, if you remember the last lesson that we drew rivets, we just used the center circle here. What you can also do, if we come out of that sketch, is do spheres. We can draw them on this face here. Okay. I don't like doing it because I find it difficult to place them. I just prefer doing it by drawing the sketch and filleting them. Okay. Each to their own. So if we go back into this sketch here, and we'll do a circle, we'll find the center point, 0.3 millimeters, and we'll define the height, 0.4 millimeters, make sure it's in the center here, and then we can extrude this out, and then fill it off to top here, 0.15. Okay, and then we can do pattern, and we'll do select those, it's time to do faces, select those two, direction upwards, we need 4 of them, okay, and then what we want to do is mirror this all across here. Okay, so what we can do is the pattern again. So if we do pattern and extrude all of that lot in that direction, we need 2 of them. How long was this face here? Need to move that slightly. Wait a minute, it's copying the whole of this face over. Let's have a look at this. Okay, so let's delete that. Come back into that one there, edit feature, and change it to new body. Okay, then what we can do is copy that over the correct distance, which is 2.883. So if we mirror that, and that, we can drag it that direction. We only need 2 of them. And then what we'll do is we'll combine that body with those 2 bodies. Okay, so now we've got those straps on both sides there. So if we grab an offset plane, change to this face, and we're going to drag it across in line at 2.6 millimeters. And then we'll create a sketch on that surface there. Okay, so we're going to have a flat back, come forward, diagonal up, and then straight down off of the front of the sole bar here. Okay, so front of the sole bar is here. So if we have a line that comes down like this. Move that point down slightly. Actually, it needs to be coincidence that line. You won't do it with that edge there. So we're just going to do it by eye. Okay, so it comes down, diagonal. Okay, so we're going to draw a line. Same height. I'm going to come down. It's in line with the it's in line with the top of the axle box here. Come forward slightly, past the spring, and then diagonal to that one. And then if I get another line, I can close that top surface there. Okay, and then I can extrude that drawing in slightly. I'm going to tell it to join. It's going to come in 0.6. Yeah, what I'm going to do is I'm going to edit that feature. I'm going to have that as a new body to start with, because I want to dig out some of this inside here. So if we spin that round and we're going to draw on that surface there, we're going to find offset, change selection, that edge, that edge, that edge. I want it on the inside to be minus 0.2 millimeters. I'm not sure that's going to print particularly well, to be fair. I'm going to cancel that. I'm going to leave it as it is. Delete that sketch, because if I dig that out, I think what I'll end up is it's not really big enough to print particularly well. So yeah, I'm going to leave that as it is there. Okay, so if we look at the next one, it's going to be roughly in line with the bottom, but it's not going to be as high as the top on this one. So again, it's got a slightly different diagonal angle here. So we have to draw that shape completely differently. Same process though. So if we come into Fusion, we'll create an offset plane, and we'll bring that across in line, about that position there. And then we'll draw on that surface there. Okay. So we know that the surface needs to be in line with this one and comes out at the same distance. So what we can do is the same lines there. We can put, we should be able to put, if I move that whole line down slightly, should be able to put horizontal constraint to those 2 points. Why has it not done that? I was expecting that to snap upwards. Let's take those out. Let's try coincidence constraints. Yeah, that's the one I'm after. So it's the same height and the same length. Okay. Then what we'll do is we'll draw a line. Let's spin that on so we can see where we're looking. Up here, so we can see how it's vertical here, because I've got that little blue square that appears in the corner, so I know that's at 90 degrees, like that. Come forwards, and I want it to be in line with this here. So if I then do escape, horizontal, vertical, that point to that point, they should then snap in line. Yep. And then we can come down, spin slightly so we can see what we're looking at. Where's my line gone? Oh, I've turned it too much. Turn onto that face there, that's it. Okay, so let's have a quick look in here. So it comes just below the sole bar and then diagonals into that one there. That's it. And then I can extrude the same distance as 0.6 millimeters. I'll take to join. And we've got to combine these two bodies, so we'll come back to this one because we were going to do something different there, so we'll just tell that to join instead. Okay, so we've now got those two parts there. Let's just check the height of this. Yeah, that looks okay. It's quite a tall part there. Okay, and then the bottom of these have both got bolts and nuts coming out the bottom, so we're just going to draw a little pipe coming off the bottom here that's connected to this back plate. So we'll draw on this bottom surface here. See how I'm making sure that part of this pipe is going to touch that W iron, so when I print it, it's going to be supported by the W iron. So we're going 0.5 and then drag that downwards. So as that prints, that'll all be part of it. So come down 0.6. What I might do is actually change the diameter slightly there. So if I edit that sketch, let's go 0.4, it's a little too thick, that's it. Okay, and we'll define distance from front edge 0.3. Let's just measure this. So that's 0.3 down here, it's 0.6. So define distance from the centre to there. It's 0.3, we know that's centred. Okay, we'll do the same on this surface here. Four millimeters distance there. It's 0.3, add it. And then if we extrude, all we have to do is select the bottom of that face and we know it's going to be the same height there. Okay, so what we're going to do is now move to the back surface and we're going to put the hole in for the actual pinpoint. So if we create a sketch on this back surface, actually if I jump across to this is a diagram I received of the pinpoint cup holder. So as you can see, it's 1.3 millimeters deep. It's got a lip of 0.25 millimeters, and the outside diameter is 1.6 millimeters of the actual cup. You will want to leave a little bit of space there though, so that the cup can actually slide into something. But you don't want to go more than 2 millimeters because that's how big the lip on the outside is. I'm not entirely sure from the diagram how deep it is, but obviously if it's only 1.3 millimeters deep, I'm going to imagine it's probably going to be about a millimeter on the inside here. Okay, so if we create a sketch on here, we come to center point circle. We'll find this midpoint here by running along here the bottom edge till we get to this triangle. We'll come up and I'm going to draw 1.8 millimeters. The reason for that is obviously it's 1.6 millimeters in diameter for the cup. I want a little bit extra. It may need a little bit more because sometimes resin swells, so you may need to drill this out a tiny little bit with a pinpoint drill just to make it perfect. Or what you could do for future runs, if you're going to print multiples of them, is obviously once you've printed the first one, you'll know how much it swells, whether it's okay or not, and then you can come back in and change the sketch in the future. So we'll just go for that 1.8 millimeters to start with. We'll define the center point with 1.65 millimeters upwards. We'll fix that in place. We'll then extrude that into the axle. If we look at this, it was 1.3 millimeters, so we'll need to give ourselves a little bit more than that. So if we extrude inwards, if we go 1.5, that should give us enough room there to fit it in all the way. And then as you can see, there's enough block around the outside to not give us a concern with this bit, this inside wall being too thin. If we look at the front surface, it's a bit close on these corners here, but that should be okay because all this is supported off of this back plate here. Okay, so that's your basic WI. Go look at this sketch here. If we look at the sketch, we've got things like there's a couple of bolts here, you could draw them on. I think there's a bit of a bent out beam here, not entirely sure what that's about. And there's obviously there's too much darkness, too much shadow in here to be able to give you a clear view of what's going on up here. But whatever you do draw, you've got to be mindful how small it's going to be, and whether it'll be able to print it or not. But I'm looking at this WI and thinking I'm pretty comfortable with how that looks. And in N-Gage, it's not going to look, you know, particularly detailed at the time you've printed it. And at the end of the day, when you're running this round on your layout, you're going to be standing 3 foot away from it. You're going to be pretty much looking at that. So the detail that you need to put under here needs to be quite minimal. I don't particularly go for drawing like all the brake rigging and things like that because you're not going to see it. If there's quite large cylinders or anything, air cylinders, then I would go and draw that in here as well. But for the WI that we're working on today, I'm pretty happy with how that looks. And if most of you copied that, you would end up with a wagon that would work perfectly fine for your layout. Okay, so let's jump forward in your sketch here, and that should then mirror those 4 WIs across around all of the wagon. Okay. One thing that you may need to be thinking about, and this is the problem with Lowmacs, is what we're going to do about the wheel here. Okay, because the diameter of a wheel, including the flanges, is 7.1 millimeters. So you're looking at 3.6 millimeters from the center pinpoint upwards. What we may need to do is dig out some of this material here to make the wheel fit inside this archway. Okay, so if we look at this back edge here, we can draw a line here and it gives us some sort of idea about how much room we've got. So as I said, the diameter of a flange on the wheels that I've got are 7.1 millimeters. So that's going to give us 3.6 millimeters from the pinpoint. Obviously 3.6 millimeters gives you no play, but looking at that, you're not going to have a lot of room here to have a wheel. I would be tempted to look shopping around, maybe see if I can find any smaller wheels. Some of the American manufacturers might have flangeways that are smaller. The wheel that I'm looking at, the wheel itself is a 6.1 millimeter wheel. So maybe if I could get hold of 5.1, something like that. I know there's some American manufacturers that do that. That would bring that down 0.5 millimeter. Then I'm only taking a little chunk out of here. But at the moment I've got no 5.1 wheels on me to double check the outside of the flangeways. But that's something you will have to potentially be aware of. And if you are looking at having to do that, then all I would do is draw. If we come out of that sketch, create a sketch on this back face on the inside here, and then draw a line upwards like this, however high you need it, down like that, and then you can just extrude this into the wheel here, into the wagon here. Obviously you don't need to start on this outside edge. What you could do is just create an offset plane from that edge and just come in to, obviously the wheel's going to be here, come into sort of this position here, so the wheel sits in like a little well here, and then you're still maintaining this chunk here without losing the integrity of the body here. So yeah, that's how I would look to go about doing that. If you get any questions, please feel free to ask. I hope you've enjoyed that and it's helped you to understand how I go about doing the WIs here. Please press the like button and please do subscribe for more content. I'm looking at coming up with a few ideas which could be quite interesting over the next few lessons. So I hope you've enjoyed that. Thanks for watching.